Are you ready for the last question? This is our last 15 marks for paper 2 and this is organic 2. Of course it's going to be organic 2, what else, right? Okay, so let's dive into it. Okay, I'm going to try to finish this in one sitting so you can see the flow of how 15 marks will feel like. Do you have the stamina to complete this? Alright, so what we have here is we have our ethanol, and they say that ethanol can be produced by fermentation, and you should know this process of fermentation really well, including the condition. So they say the first thing is name the substance that's added that caused fermentation. You have seen this in bio as well, so there's no way you can get the word yeast wrong over here. Okay, the ideal temperature is 37 degrees, so it should be there. 37 is actually the optimum, so it's the same as your body temperature. And next one is explain why fermentation is done in the absence of air. So you do need to know that for fermentation to take place, you need yeast to get it started, optimum temperature of 37, and it must be done in the absence of air. So why is this so? So you need to explain why. First thing is that if there is air, then the ethanol would be able to react with oxygen. So take note, oxygen is the one, the gas in the atmosphere that we do not want ethanol to react with. Another way to put it is ethanol would be oxidized. The idea of oxidized is basically reaction with oxygen. And what would it form, right? What would it form? It will form ethanoic acid. Now, if you don't want to write ethanoic acid, you want to keep things general, you could also say that ethanol will be oxidized to form carboxylic acid. Carboxylic acid is essentially the homologous series, the family, and ethanoic acid is the second in the carboxylic acid family. Alright, so there we go. We've got 4 marks in our pocket already. 4, 5. And what part B does is, when you see this kind of question, is you need to know that you need to calculate molar enthalpy change. And molar enthalpy change require you to identify what bonds are being broken and what bonds are being formed. So let's go up to the diagram. Let's not overcomplicate things. All I usually like to do here is to draw a middle line, okay, the middle line, to allow me to see where are the reactants, because the reactants bonds needs to be broken first before I can form the products. So let's take a look at the reactant, okay? All in all, as I mentioned here, there are 5 bonds that will be breaking, 5 types of bond that will be breaking, and the clearest one is actually our oxygen OO double bond there, and there are 3 of them, okay? And that's the first type. The second type is the bond between the C's, that's the second type, and then the third type would be, I'm going to use another color, the CH bond, and there are 5 of them, 1, 2, 3, 4, 5. And the fourth type would be our CO bond, the bond between the C and the O, and the final 5th type here would be between the O and the H's. So what you need to do is, say for example, you are looking at 3 sets of O double bond, identify the O double bond, there are 3 sets, and you multiply that 3 sets by 4, 9, 8. So this is what I've done as part of my working for my reactants. So that's my oxygen. Okay, and what exactly is this 5 times 4, 1, 4? So I've got 5 sets of CH bond on the reactant side, as you can see in blue. So that's why I multiply. So basically, for my bond breaking part, I am trying to identify what type of bonds are there and how many of each type. So if there's 5 of CH bond, I need to multiply 5 by 414, and I basically add up every bond that is breaking on the reactant side. Okay, and we go to the product side. Now for the product side, there's only 2 types of bond that is being formed. So after all the atoms come apart, they can come together to form the product. So the first type is the CO double bond. Take note, it's the double line between C and oxygen. So when you are looking at this table, take note, we are looking at this value, not this one. Okay, so take note of the number of bonds between the elements. So CO double bond, and there are how many of them? I've got 1 set, 2 set, 3 set, and 4 sets. So what I'll do is I'll get 4 multiplied by 804, and you can see it over here. And then I'll do the same for the bonds that were formed between the O and the H's. I've got 1, 2, 3, 4, 5, 6. So 6 multiplied by 463, and that's how I get to a total of 5994 kilojoules per mole for my bond forming the product part. So then, in order to get your final marks, which is 3 marks here, you need to calculate the molar enthalpy change. So what you do is you use the bond breaking, which is in green, 473, minus the bond forming, which is 5994, and you actually end up with a negative value. Now please don't panic when you end up with a negative value. What this negative value basically tells you that this reaction is exothermic. It gives out heat. Okay? So before they ask you about the exothermic endothermic reaction, they want you to draw an energy level diagram. And how this might look like is this. At the end of the day, if it's an exothermic reaction, it shows that the product has less energy, okay? Product has less energy than reactant because heat energy is lost to the surrounding. So your product would be on a lower, okay, product is lower than reactant. If you can already show that the product line is lower than the reactant, you actually get your first mark. Okay? Then what else do you need for this? You need, because you're drawing just an energy level diagram, you don't need to have that activation energy hum, which I'm going to draw for you in a while. Okay? What you need to do next is you need to label it clearly. And what do I mean by label is if you look at the reactant, you basically copy and paste exactly what the equation is providing. The reactant is here, okay, including the balance stoichiometry number. So 3 before the O2 is important here. And you write that for the reactant, which is the line on the extreme left, and you do the same for the product. Okay, this is how it looks like. So by writing out the complete equation on both the reactant and product side, you will get the next 2 marks. So this is a very simple energy level diagram because there's no need for you to include what we call activation energy. Now, I'm going to take a moment to include what we call profile diagram, energy profile diagram. How this will look like is the same 2 lines. With the same like C2H5, OH, basically everything that you have over there, but you need to include, just going to write this activation energy hum, okay? I am going to remove the pixels, okay? I'm just going to zoom in a little bit, and this is what we meant by energy profile diagram. You need to include what we call activation energy, and this enthalpy change, delta H, which is going to be a negative value. If you want to be precise, you can just copy the number at the top. Negative 1263 kilojoules per mole. That is our energy profile diagram. Sometimes it can be quite generous, giving up 4 marks, but then there's a lot more tedious things to take note of. Like for example, your line needs to be the same level as the product, and then the direction of the arrow needs to be clearly annotated. If not, you will not get full marks for energy profile diagram. Okay. Now, this next 2 marks is hard to score for a lot of students, so please take note. They want you to explain in terms of bond breaking and forming why this reaction is exothermic. So we go back to our calculation, and you can see the reason why it's exothermic is because the bond breaking part require lesser energy than the bond forming part. So how do you put it into wording then? There are 2 different ways to explain this. My personal favorite is purple, but you can always go with the red and blue answers combination. This will also get you 2 marks, okay? So some students like to be very clear that they like to mention from the beginning that bond breaking is endothermic and bond forming is exothermic. That's fine, that's a 1 mark. And in this case, you have to apply to the context, right? Apply to context. In this case, more energy is released than taken in. So the overall impact is this reaction is exothermic. My personal favorite is like this: more energy is given out during bond forming than taken in during bond breaking. It is essentially the same answer, but it is just my preference of the way I word things out. Okay, if your wording is slightly different from favorite, feel free to send me a DM. I'll be happy to take a look at it for you. Okay, all right, this one, part C. This is the last part here. We have got an ethanol, and how do I know it's an ethanol? Is because if an OH, a functional group of OH, mixed with compound A, and I get an ester. So you can work backwards. This compound A would definitely be a carboxylic acid. And carboxylic acid has a functional group of COOH, right? So they are asking you to draw out compound A, draw the display formula. Just want to highlight display formula here means show every bond. That means you must show every line, okay? And you need to show compound C as well. During esterification, you have actually got a small molecule of water being formed. So most students will be able to get this. Now, to get compound A, what you need to do is from ester B, which is over here, you need to know where's the ester linkage, and this is over here. Ester linkage is the COO part. And the part that's ethanol and carboxylate joins, this is where it is. So this is the line, and the part that comes from the carboxylic acid would be where the C double bond O will sit, right? So this one comes from the carboxylic acid. So you draw out this entire same structure over here, like here, right? And then you add in the part that has been given away, which is the OH. So you add in the OH, and you will be able to get compound A. Okay, so where is the OH going to? Eventually the OH goes into the production of water. So carboxylic acid loses the OH, while alcohol, in this case the ethanol, it loses the H here, loses the H here. So we actually end up with a water, and that's our compound C. That's how we draw it. And finally, to name this compound, you need to know what we are starting with. The name is ethyl ethanoate, and how do we get that? Okay, it starts off with ethanol, and how do I know it's ethanol? Because there's two C's, right? Ethanol, and then if you look at our compound A also have two C's. So we start off with ethanoic acid. Okay, so both of them have two C's each. So the final name of the ester, the beginning part, will come from the alcohol, which is ethanol. But we change the ethanol to ethyl, YL, and then the second part comes from the carboxylic acid. So if the carboxylic acid is ethanoic acid, it will become ethanoate. Okay, so that's our last 15 marks. Is that easy or difficult for you? Alright, if it's a little bit of a challenge and you still need a little bit more guidance on Organic 2, please feel free to drop me a comment or just DM me on IG. I'll be happy to do a few more Organic 2, because I know this is one of the chapters that students tend to be fearful of for paper 2. It's a large topic to begin with. Alright, so as always, thank you so much for being here with me. This is the end of paper 2. Hopefully you have learned something and it has boosted a little bit of your confidence and give you some clarity on how to tackle 2025 paper 2 question. If you have any more questions, feel free to ask me on IG. If not, please like, subscribe and share with a friend. Thank you.